Ethan, I have had 4 brain surgeries, and every single one has zapped my memory a little bit more. I am now like Dory from Finding Nemo. So I feel you on the memory thing. I used to have an amazing memory. Now I'm Dory from Finding Nemo. So last time I saw you, we started in introducing functions, and today we're just going to be talking about linear relations and their graphs. And your homework will be basically graphing linear relations. When we talked about relations last week, I told you that they were just sets of ordered pairs, right? That you could write in the form of a graph and they can be expressed as an equation. In this case, all of these sets of ordered pairs that we have form a line. Sets of ordered pairs that form a straight line. Get it? A line and linear. See how uncreative we are in math? Right? Everything we do is kind of named. How do these points and the line relate to each other? And the equation that we use is called a linear equation to express the points, how those points change in that line, right? We're going to start off talking about the standard form of a linear equation. Why we talk about the standard form of a linear equation in most instances is beyond me. Because the useful form of a linear equation is the slope-intercept form, which we'll talk about in a couple of minutes. But the standard form of a linear equation is one in the form where we have ax plus capital B y. That is not an 8, that's a b. I will fix it so it looks more like a b, because otherwise you'll be thinking all your y's have an 8 in front of them, and that would be wrong. In this circumstance, a has to be greater than or equal to 1. So we don't have any negative a's in that. If we're given something with a negative a, we need to put it in standard form by getting rid of the negative. If it is in a fraction form, then it would be less than 1, and we would have to eliminate that fraction. So if I'm given, for example, negative 5x plus 6y equals negative 12, and I'm asked to put this in standard form, put in standard form. What is the only thing keeping this from being in standard form right now? It's tricky. No, y is good. Look at this little rule I have on here. A has to be greater than or equal to 1. Is our a greater than or equal to 1? Is what is in front of our x value greater than or equal to 1? No, we got that nasty negative in front of it, right? We can't have a negative for standard form. Does anyone know how to get rid of a negative that we don't want? Besides just erasing it. Nope, that's a really good guess. If we were moving it over, that would be perfect, Jeremiah. But we're just trying to get rid of the negative. We're not trying to move the x part out of the way. Otherwise, that would be super effective. multiply by a negative or divide by a negative. If you're just trying to change signs on something, -1 is the answer. Multiplying or dividing by -1 is always the answer if you're just trying to change the sign, right? No matter what circumstance, if you have an equal sign, you're just trying to change the sign, just multiply or divide everything by -1. And it will change, it won't move anything, it'll just change the sign of everything. So this would become 5x minus 6y, but we're allowed to have a negative on the y, equals positive 12. Right? So all that did is change the signs of anything. And someone said, Sergio said multiply by a negative. We could have multiplied the whole thing by -1 as well. It would have had the same effect, right? I just didn't have anywhere to write the -1 on this side here, so I thought it was easier to divide. Either way, the outcome is the same, right? And so now we have this standard form of an equation. What if I have, I like using this one because I would never change this form. I like it in the form that it's given in. Y equals 2x minus 9. And I need to put in standard form. What's keeping it from being in standard form? What is preventing us from having standard form on that? What needs to be moved? So you're all throwing it at me in the chat box there. If you look here, on this side, I have my x value and my y value, right? But on this side, my x is on the wrong side, right? So I need to move that x over here, right? How would I go about doing that? Jeremiah knows the answer. Add by the opposite sign, right? So we have positive 2x. So we want to move it over. So we're going to go minus 2x minus 2x. So I get negative 2x plus y equals -9. Now, I'm still not quite in that standard form, right? So we are going to go ahead now and we're just going to divide everything by -1 or multiply, your choice. This becomes positive 2x minus y equals 9. Right? I want to show you one with a fraction, and the reason for that is that you need to know how to clear a fraction, right? If you've got it. So if I have 1/6 x equals y minus 2, and I want to clear that fraction out, you're actually, Jeremiah, you are right. We're going to multiply by 6, but we're going to multiply the numerator. We're going to multiply the top because that's what will cancel it, right? It's like saying I have 1/6 and I'm going to multiply it times 6 over 1. So I would have 6/6, right? Does that make some sense? If I had 1/3, I would multiply times 3 because that's the same as 3 over 1. I get 3 over 3, and that just equals 1. So Jeremiah is right, though. We are multiplying by 6, right? And we're going to multiply everything, the whole thing, by 6. right? I can just write the 6 next to it. I don't have to do 6 times, but whatever. No, because if I multiplied 1 6 and I multiplied the denominator times 6, right? If I'm just multiplying the denominator, I'm left with 1/36. Doesn't cancel. Yeah. So when I multiply this times 1 6, I'm just left with x equals 6y minus 6 times negative 2 is negative 12. I almost forgot to write the y there. And so we got rid of that denominator. The only thing left we would have to do on this is to move the y to the other side, right? So I'm going to subtract 6y from both sides. And I'm going to write this as x minus 6y equals negative 12. Does that all make sense to you guys as far as moving those things around? You want it in an xy form on one side equal to the number on the other. Clear your fractions. And if there's a negative in front of the x, you're going to clear that out too. Like I just got shot video of myself drinking coffee. It's going to be one exciting video today because I'm sipping my coffee in it. So now that I showed you standard form, I'm going to show you the form we actually care about, which is slope-intercept form. The exciting thing about math is that we are not very creative people, us mathematicians. That's not true. I'm a very exciting person, but I'm not a good mathematician. Intercept form. Like I peaked with my BS in math. Slope-intercept form you guys have used before. You will recognize it as soon as I write it. It is the one of that form y equals mx plus b. You've all seen it before. You missed it. I know you have, right? Slope-intercept form. It has a slope and it has an intercept. That's how creative mathematicians are right there. Your m is your slope of the line. B is your y-intercept. Now, a slope, I like to think of it as our up and down over our side to side. We call it rise over run. I really like to think of it in terms of up and down over side to side, though, because sometimes you're not rising, you're falling, right? So if I had a slope that said like 3/2, that would mean if my m equals 3/2, that means I'm going to go up 3 units and I'm going to go this way 2 units. Right? If I have a negative 3/2, I want you to think about this. One of them has to go up, one of them has to go down. It doesn't matter where I apply this negative. Whether I apply it to the numerator or denominator is not important, as long as I only apply it to one or the other, right? So I could say that this one is going to go down 3 units and then positive 2 units, or I can say it's going to go up 3 units and this way 2 units. Does that make sense? What if on this one I've got my positive 3/2? Would it be the same if I went down 3 and then negative 2? It would be exactly the same thing, right? And we'll get into that a little bit more, but right now I want to talk to you about what a y-intercept is. Does anyone remember what a y-intercept is? Did you just say yes? It is. It's the point on the x-axis, right? So y equals mx plus b means that we are crossing this y, sorry, it's point on the y-axis. We are crossing y at point B, right? And the x-intercept would be where we cross the x-axis. A y-intercept is where we cross the y-axis. And it's super helpful to have stuff in this form, right? So before I start putting things in that form, let's talk about different types of slopes. I'm going to make you 4 graphs. They're going to be very little graphs. One is going to look like this. We're not going to put any numbers on these graphs at all. Just going to talk about them a little bit because we're talking about slopes and intercepts. Oh, that is not the straightest of lines, is it? So if I have a line that is increasing from left to right, we call that a positive slope. So anytime you have a slope in front of your x that does not have a negative, it should be increasing from left to right. If your slope has a negative, it is going to decrease from left to right. It would be a negative slope, right? Because it's going towards the negative. This one's going forever and ever positive. This one's going forever and ever negative. If I have a horizontal line, it has a 0 slope. When you see something like this, it will normally have a y equals something. We'll call it a, but that a can represent any number, but you're not going to have an x value in there, right? Because x is always going to equal whatever that a is. Say it was 3, x would always equal 3 in that, right? For every value we put in for x, we're still getting a 3 out. The last one that we have is if we have a, let's see if I can make this an actual vertical line. I'm having a lot of hard time making straight lines today. It's like the weird twist on my hand from where from where my tablet is. I do not know why I'm struggling so much with that. I'm gonna have to bust out my ruler. So if I have, pretend that that's an actual straight vertical line, this would be an undefined slope. It would be written as x equals something, right? Any number. We'll call this one b, though. I don't want to use b. You know why? Because we're using b for the y-intercept, so we'll call this one a as well, right? It's saying that x equals something. No matter what y is, x is always going to be a, and it's never going to cross, so you won't see, like here, you're not going to see an x in this equation because it's never actually going to cross that x-axis, right? Here, you're not going to see a y because it's never going to come over here into y, right? It's always going to be the same. So you're going to be asked to graph. Mostly what you're going to be asked for in your homework tonight is going to be writing things from standard to slope intercept form, and then you're going to be graphing equations in slope intercept form, and then there's going to be a little stuff with parallel and perpendicular lines, right? But parallel and perpendicular is super easy. So let's start with if we were graphing y equals negative 2/5 x plus 7, right? I'm given every piece of information I need in this equation to graph the line because I have a point right here on y equals 7, and then I have a slope to find my next point. So if I make a graph, I almost forgot I did a little something so I didn't have to draw all my graphs, but I forgot to bring it up. I'll bring it up on the next problem. So here I know I've got to point at 1, 2, 3, 4, 5. Guess I need to make it a little longer. 6, 7, right? I know I have a point on y equals 7, right? So my next point is going to depend on my slope, right? My m equals negative 2/5. So I'm going to start at this point here, and I'm going to count down 1, 2, and I'm going to count over 1, 2, 3, 4, 5, right? 1 is going to the positive, 1 is going to the negative. It's a negative slope though, so that's kind of what we want, right? Because it came to negative 2/5. Does that make some sense? We came down 2, we came over 2. We could have gone up 2 and then to the negative 2. It would not have mattered. It would have been on the same line. If I would have had this arrow keep going, it would have just crossed at this point too, right? What if I have something written as f of x equals negative x plus 2? Sometimes it will be written in the form of a function. Just look at that function name and call it y. Y equals minus x plus 2. When we're graphing it, it's the same thing, right? On this, my y-intercept is 2, but my slope is negative, which just means it's negative 1. And I could write that as negative 1 over 1 if I want to make sure and see what my rise over run is, right? I know I'm going to have a point here at, let's call this 1, 2. And so I'm going to use my slope to find my next point. I can go down 1 and positive 1, right? Or I can go up 1 and negative 1. Doesn't matter. Or I could do both. So I could go down 1 and to the positive 1, or I can go up 1 and to this side 1. Doesn't matter, right? Because it's a negative slope. I made a really straight line right there, but I still didn't get through the point. I'm just going to make the point bigger so it looks like I got through the actual point. What if I'm given this point? What if I'm given a function or an equation in standard form? X plus 3y equals, it says negative 15 on my paper, but I don't want to make a graph that's that big. So I'm going to call it 7. I'm going to call it 4. Because I don't want my graph to be too big. So I'm just going to change the number. We'll make it negative 4, just for funsies. I need to put this in slope-intercept form first, right? Number 1, put in slope-intercept form. How do I do that? I'll tell you. I'll tell you how to do it. If you want to put something in slope-intercept form, it just means solve for y, right? Isolate your y value. Get it all by itself. You'll be in slope-intercept form, right? So let's look at what's being done to this y. We've got this x being added to it, and we've got a 3 being multiplied to it. And so we're just going to start working backwards on that. We're going to start by subtracting x from both sides. And I'm going to have 3y equals negative x minus 4. Right now I'm wishing I'd have stuck with that 15, except because when I divided it out, it would have been pretty. Now it's not. Can I change that to a 6? Let's change it to a 6. Only because I want it to divide evenly and I don't want a fraction at the end with the. So I'm going to divide this by 3 and this by 3 and this by 3 to get that y by itself. And I get y equals minus 1/3 x minus 6 divided by 3 is 2. Do you see why I changed it to a 6? Because I didn't want a crazy fraction for my intercept. So now I've got it in a form where I can graph it, right? All of our problems have had negative slopes so far. So I got my 1, my 2, my 3, my 4, my 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. So when I go to make this graph, what do I know about it? I know I have a point, right? My intercept. And I have my slope. So my intercept means that I have a point at -2 on the y-axis. My slope means I have -1/3. It means I can go down 1 and over 3, or I can go up 1 and in this direction 3. Doesn't matter. We can do one or we can do both. Let's start with up 1 and over this way 3. Or we could try down 1 and over this way 3. Doesn't matter a whole lot, right? Because they all will fall on the same line. See how I didn't make my line straight, but I still kind of made it go through all the points? That was mad skills. Let me say so myself. Does that make some sense to you? Does anybody not get how we're graphing these? Because I don't want to move on to the parallel and perpendiculars if you don't know. If you're confused at all. All right, nobody's saying anything, so I am moving on. Parallel and perpendicular lines are cool. Does anyone remember what a parallel line is? Exactly, they never touch. Parallel lines are two lines that are always going to be the same distance apart no matter what. They will never intersect because they will always be the exact same distance apart. And if you think about them, like say they're going like that, or they're going like that, or they're going straight across like that, they're always going to have the same slope, right? Because they're always going to be that same. Yeah, exactly, Ethan. Ethan got to it before me. Parallel lines have equal slopes. Right? The slope never changes. He's brilliant. I don't know what to tell you. Perpendicular lines, does anyone remember what a perpendicular line is? They do cross, Valerie, yeah, they cross at a T. They're lines that cross at a right angle. Right? But they have something in common with their slopes too. And that perpendicular lines have opposite reciprocal slopes. I'm not going to tell you what that means. I'm just going to make you guess. Not really. So if I have parallel lines, if I'm writing the equation of a parallel line, I would have like maybe y equals 2/3 x plus 7. And a line that would be parallel to that would be y equals 2/3 x plus 412,003. Right? No matter what, those lines are always going to be parallel. they are going to be 411,996 units apart all the time, right? And they have the same slope. It's always going to be 2/3 x for each, no matter what. And anything with a slope of 2/3 is going to be parallel to those lines, right? Perpendicular lines have opposite reciprocal slopes. So if I have y equals 2/3 x plus 7, a perpendicular line would have an opposite sign, so it would be negative. And I'm going to flip the fraction. And it can be plus anything. We can call it plus 7, but it could be plus anything, right? As long as their slopes are opposite and reciprocal, right? So opposite sign, flipped fraction, those lines will be perpendicular. So if I definitely want to bring this up because this is where people always mess up. If I have a line that is y equals negative 2x plus 3, and I need a line that is perpendicular to that, it would be y equals positive. Remember that negative 2 is the same as saying negative 2 over 1. So when I flip that fraction, it's going to be 1/2 x plus, it can be anything, plus whatever, right? Doesn't matter. So don't mess that up if you don't have a fraction, make one, right? Just put a 1 under whatever that whole number is and flip that. You'll be asked questions like, hey, is this parallel, perpendicular, or neither? And it'll show you two lines. It won't always be written in the form you want it to be written in. Sometimes they'll be in standard form and you're going to have to get them over to slope intercept form so you can know. Like if I have 10x plus 5y equals 5 and negative x equals 2y plus 16, and you have to let me know, is it parallel, perpendicular, or neither? First thing we're going to do is we're going to get rid of this mess a little bit, right? Because this is all divisible by 5. So I'm just going to divide this by 5, this by 5, this by 5. So I could be working with smaller numbers. And I would have 2x plus y equals 1. Right? And now I'm just going to solve it for y. I'm going to subtract 2x from both sides. And I get y equals minus 2x plus 1. So this one we're going to have to solve for y as well. Right? I'm going to start just by moving the 16 over because then I can write it the other way if I want. So I have minus x minus 16 equals 2y. But I can write that the other way if I wanted. It doesn't change anything, right? If I wrote it as 2y equals minus x over, minus 16, I haven't changed anything, right? Because they're equal. I can put them on either side of the equal sign. The last thing I have to do is I have to divide everything by 2, right? And I wind up with y equals negative 1/2 x minus 16 divided by 2 is 8. So are these equations, if I look at them, are they parallel, perpendicular, or neither? Everyone put an answer in the chat box. Parallel, perpendicular, or neither? Need more answers in the chat box. Does anyone think anything other? I got a neither. My neither is correct. Because although they are reciprocals, they aren't opposite reciprocals. Right? It's not parallel and it's not perpendicular. They would be neither. Look at the signs. They have to have opposite signs to be perpendicular. So although we did have a reciprocal, right? 1/2 is the reciprocal of 2. I would have to have a positive 1/2 here for them to be perpendicular. Want to see a cool one? It's relative. You know, I'm a math nerd, so to me, it's a cool one. What if I have x equals 2 and y equals 2? This one's not necessarily going to follow your form too much, right? Oh my gosh. Here's what I'm going to do. I'm going to erase that. Bring this in. I did this specifically so I wouldn't have to draw graphs all the time. I made sure I had one. What if I had, so if I have x equals 2, that means this whole line right here, right there. And if I have y equals 2, it's this whole line right here, right? They're actually perpendicular, right? Think about this. If x equals 2 is a straight horizontal line, and if y equals 2 is a straight vertical line, they're going to cross each other at opposite reciprocal angles. That's my little trick one right there for you. I'm trying to write with the eraser now. Does that make some sense? Right? We form these right angles here. Jameson's the winner of the day today for catching that this was neither. So you win 8,000 imaginary puppies. Try feeding them. It's like crazy. You'll have to get up early. That is the bell, and that is all I have for you today. Your homework is in Delta Math. It's all these kinds of problems, right? It'll be a lot easier though because they'll give you the graphs. So have a fantastic day. I'll see you guys on Thursday. Let me know if you have any questions. You still can't get into Power School, Jeremiah? Like what happens? Is it saying that you have to be 18 still? Because I thought they got that problem fixed. I can stop screen castifying.